So this is the tangential acceleration, and this normal acceleration is always towards the center of curvature or the center of the circle. So, and then A is the vectorial addition of the tangential acceleration plus the normal acceleration. The normal component of acceleration represents the time rate of change in the velocity's direction. The direction of normal acceleration is always towards O, the center of the circular path, as shown in figures E and F. Like the velocity, the acceleration of point P can be expressed in terms of cross product. Taking the time derivative of that, we have A is equal to dv dt, and V is the omega dt cross Rp plus omega the Rp dt. We have that V is equal to omega cross Rp. So we now have that d dt will now be equal to d of this dt. Because this is a product, so you first of all say d omega dt cross Rp plus d r dt cross omega, sorry, it's omega cross omega, since that's r cross omega. So by recalling, the omega dt is alpha. So the omega dt is alpha, and then the Rp dt is V. When change in displacement per unit time is velocity, and velocity is omega Rp, that is omega r. So we can now turn this to its appropriate terms, which will now give us, this is alpha, this is Rp plus omega, then the Rp dt is omega cross Rp. So we now have triple multiplication here. So which will now give us, we already showed that acceleration is the vectorial sum of tangential acceleration plus normal acceleration. And the tangential acceleration is alpha r, alpha cross r. Then the normal acceleration, so omega cross omega, then cross Rp is omega, is minus omega square r. So since tangential acceleration and normal acceleration are perpendicular to one another, if needed, the magnitude of acceleration can be determined from the Pythagoras theorem. So A is at squared plus an squared, which is indicated here. So let's look at one tutorial problem or one example. The color C in figure A is moving downwards with velocity of 2 meters per second. This is a column and it's a rigid body. And then this color, point C, only moves downward with velocity of 2 meters per second. And this point B will move towards the right and then upward. At this point, this guy, this arm, AB, this body, AB, will be making rotational movements, rotational here. But this guy, CB, at this point, is moving in the y direction, that is rectilinear motion. But here, at point B, is moving in the circular motion. That circular motion and then rectilinear motion, it makes link CB to be in general plane motion. So using vector analysis, determine the angular velocity of members CB and AB at this instant where it is going downwards with velocity 2 meters per second. So let's look at the solution. We said we should use vector analysis. So we'll first of all look at the kinematic diagram. So the downward motion of CB causes point B to move to the right along a circular, along a curved path. It will move to the right like this. Also, CB and AB rotate in a counterclockwise. Because as this guy, point C, moves down, this will move like this. So, that velocity equation. So, as I have said, link CB is in a general plane motion. So, this is CB. At this point, the guy is moving down with velocity 2 meters per second and is moving to the right with velocity VB, which we have not known, which we need to determine. Therefore, we know that from our formulations, VB is equal to VC plus omega CB cross R of B with respect to C. So VB has the X component, has the S component. VC is 2 meters per second, but only Y component. Only Y component. And since it's moving downwards, it's in the opposite direction of positive Y. And then omega CB is what we are asked to find. Then cross RBC, this point is shown that is 2 meters, is 2 meters in the X direction and 2 meters in the Y direction. But the Y direction is downwards, So we now cross this out. We cross this out. K cross I is equal to J. K cross J is minus I. Times minus will give us plus. So from here now, we can say that VB is 0.2 because of what? We equate the I components, then we equate the J component. So VBI is 0.02 omega CBI. So these are the two components, the X direction and the Y direction. So from there, we can find that omega CB is 10 radians per second. And then VB, that is the velocity at this point, is 2 meters per second. So since link A rotates about a fixed axis and VB is known, its angular velocity is found to be VB is equal to omega R. So that is 2 is equal to omega AB. We know R AB to be 2. So from there, we can find our omega AB to be 10 radians per second, which is the same thing as CB. So thank you very much. This is the end of part A. Do not forget to like my videos, subscribe to my videos, then share the videos, press the notification bell for new videos. And then if you are one of my university's undergraduate students, please do not forget to subscribe with your real name so that we can have more interactions. Thank you very much. See you in my next video.